Good afternoon, everyone, and thank you for the introductions. My name is Lucy from Japan, which is 13 hours ahead. So I will apologize first if I fall asleep, and plus after lunch. So, as Alex mentioned about water contaminations, and Lisa talked about recycling gloves. So I also do believe that if there is a field that people can think globally and act locally, it is addressing environmental issues through science and technology. So with that, I'm pleased to present part of sustainability projects with the title From Waste into Energy. Some of you might have seen pictures of turtles or other ocean animals deformed or suffered, being trapped in plastic, or particularly plastic ring, that the plastic just flown into the oceans. Well, plastic pollutions, particularly non-recyclable plastic waste, is a serious environmental problem. With the increasing populations and with the consumption rate, we create more and more plastic waste. And in Japan, if you go to department store or supermarket, they will give you very nice packaging after packaging. So a lot of plastic waste there. So. And the bad news about this plastic waste is, unlike paper or organic waste that can be degrade, but plastic waste need incredible long time to degrade. So we cannot easily get rid of plastic waste. That's the reality, the bad news. And we also understand that reusing or recycling plastic waste is a preferable way to deal with plastic waste. However, there are certain of plastic waste that we cannot simply reuse due to material reasons. And for this non-recyclable plastic waste, the chemical recycling is an effective way to deal with this non-recyclable plastic waste. So chemical recycling aims to turn this non-recyclable plastic waste into fuel. So we turned unused resources into added value products. So as we can see that some countries produce a lot of plastic waste and they still import oil. So imagine if we acquire the know-how to generate energy from this plastic waste into into fuel. So as the plastic waste is originally created from crude oil, so we can change it back into oil products. And with pyrolysis or the thermal depolymerizations that break down these long chains of polymer chains, carbon chains, we break it down and then we turn it back into the origins of the plastic waste, the crude oil. So basically, that we need is not all material of plastic. We need PE, PP, and also PS can be used. PE for polyethylene, PP propylene, and polystyrene also can be used. But the others, if you use PVC, because it contains chlorine, so we cannot really go into for the feedstock. So we basically the pyrolysis includes the process of the mixing and the cracking of the feedstock of the plastic waste, and then we also break down the hydrocarbon from the mixture, and then the last we distill the crude oil, the end products. And this I show the advantage of chemical recycling. So landfill or sometimes incineration is commonly used for disposal of non-recyclable plastic waste. But both of these short ways are not sustainable. But with this chemical recycling, we can deal with plastic waste economically and eco-friendly way. So we turn this non-recyclable plastic waste back into oil products. And in addition to the less emissions of greenhouse gases, and also create a job in the local community. And we hope if the oil products can be scaled up to the industrial scale, it will also create a job opportunity. And to end these presentations, I want to quote what Brundtland said for sustainable development, that our development now, that we meet the needs of the present, but we also need to consider the ability of the next generations to meet their needs. That's sustainable development. Thank you.